Welcome everyone to the Greene County Well Water Monitoring Program. This presentation is going to highlight the results from 2021, which is year 3 of a 5-year monitoring program here in Greene County. In the time we have together today, what I'd like to do and cover in this presentation is just provide some of the basics of groundwater. We'll provide an overview of the project goals and the process used to select results. We'll talk about the individual tests that were performed and why those tests are important, and discuss what we've learned so far about groundwater quality in Greene County. Lastly, we'll talk about what comes next. So looking forward in years 4 and 5, what are the next steps for this project and what else do we hope to accomplish? Just so that everybody's on the same page, when we talk about groundwater and where well water comes from, it's important to have some understanding of the water cycle. And groundwater is just rain or snow that melts, and some of it soaks into the ground. Eventually that water is going to reach a point below the land surface where all the cracks in the rock or all the spaces in between the soil particles are filled with water. And that's our groundwater resource. Groundwater is always moving through those empty spaces in the soil or the rock from areas where it infiltrates or soaks into the ground, and it's moving to what we call discharge areas. And those are going to be nearby lakes, rivers, streams, or wetlands. We use wells. People that live out in rural areas use private wells to access that groundwater resource, which intercepts some of that groundwater along its flow path. And it's really important to understand that our water quality is largely determined by the soils and the rock that water passes through, but also the land use where that water infiltrates or soaks down into the ground or into the soil. So we call water the universal solvent because it has a great ability to dissolve stuff. As much as we all would like to have pure water, in the environment, we never find pure H2O. Our water, particularly groundwater, is always going to have impurities. Again, depending on the types of rocks, minerals, land use, even the types of plumbing and packaging that water is stored or transported in will impart different impurities to our groundwater, our drinking water. Also important to point out that if we find certain impurities that cause health issues or can be considered health contaminants, there are levels at which certain impurities can cause those health complications. If that ever occurs, we also have treatment abilities that can make water safer to drink. Ultimately, that's a short-term solution, and we'd like to strive to reduce the contamination at the source rather than having to rely on water treatment. But that oftentimes is a short-term solution or a more immediate solution to long-term challenges associated with some of these particular contaminants. So just providing, kind of an overview of the project itself. This project was initiated in 2019 by Greene County in partnership with the Greene County Extension Office, the Health Department, the Land Conservation Department, and others, with the goal of learning how well water quality is changing over time in Greene County. Many counties have good baseline data, thanks to the good work that Greene County has done with voluntary testing programs. Greene County knows a lot about baseline well water quality, but what's lacking is the ability to really understand how is well water quality changing. Is it getting better, worse, or staying the same? So that's probably the primary goal of this project, and we've designed it with the intent that it's like the Dow Jones Index for well water quality in Greene County. It provides a little bit more immediate assessment to understand that particular question. Also, in in combination with that goal is this idea of, if well water quality is changing, what can we learn about where those changes are occurring, and hopefully understand a little bit about why those changes are occurring. This project works best when the wells are representative of the diverse geology and land use of the area. We feel we've done a good job of selecting wells from across the county that meet that objective. It also works best when the same wells are sampled every year. So all of the people that participated, our goal is to get as many people as possible to test in all 5 years of this project. In year 3, people that participated may have recalled receiving their sample kit in the mail in October. Participants would have collected their sample in October, November, or December and mailed them back to the lab. In December, we began analyzing those samples. We completed the analyses sometime in late December, early January. We then printed off and mailed out the results. We are currently in the process of further analyzing the data and looking at adding functionality to some of the tools and resources that are a part of this project. Just kind of highlighting, that original year, the initial recruitment, we reached out to 770 participants. Of those 770, 388 people responded that they would like to participate and were mailed a sample kit. In that first year, of those 388 participants, 348 actually submitted a sample. In 2020, those 348 people from 2019 would have been mailed a sample kit with the intent that they were going to sample again in 2020. Of those 348, we received 323 samples for 2020 or year 2 of the project. For year 3, we are now sitting at 307 samples received. Our goal is that by the end of year 5, we have at least 240 participants that have sampled in all 5 years. So we have planned for a certain amount of attrition in this program, and we feel pretty good that as long as these rates of testing hold steady, that we will meet our objective. That being said, we want to lose the least amount of participants as possible. So we really appreciate those that have participated, and we really hope and are striving for as many of those 307 people to continue participating in this program. I want to highlight the project dashboard that was launched in 2021, earlier, or I should say 2020, and has been actually, it was launched in 2021, and we will be updating it here in 2022 with the most current information. I will provide an overview of that dashboard at the end of this presentation. So getting into the tests and which tests were performed, nitrate and chloride are probably the main interest of the well testing program. Both of these parameters are related or influenced by land use, and they give us some ability to understand how well water quality is changing over time with respect to human activities that occur on the landscape. Other things that were included are things like total hardness, alkalinity, and pH. These are tests that are able to help us better understand how the rocks and soils are impacting groundwater quality. And then lastly is this test conductivity, which is kind of an overall water quality test that gives us insight into both the land use, the rocks, and the soils. Conductivity is kind of an inexpensive test that may provide some more real-time water quality assessment moving forward, but really useful to collect background information through this program that might help inform maybe more real-time assessments of groundwater quality or well water quality in the future. When we look at the hardness test, hardness, again, is naturally occurring. It comes from the rocks and the soils. This is primarily a measure of calcium and magnesium, which are going to come from the water flowing through carbonate rocks. So carbonate rocks, think limestone, think dolomite. That water is going to dissolve small amounts of calcium and magnesium from the rocks and the soils that it passes through. Hardness is not a concern for health, but it can cause some aesthetic issues, mainly scaling on fixtures, maybe soap scum. People with hard water tend to use more detergent. People with hard water, over time, if that scale develops on a heating coil, and let's say an electric water heater, that may decrease the water heater efficiency over time. So too much hardness can be problematic for those reasons. And people with what we would consider to be hard water would be those with levels greater than about 200 milligrams per liter of hardness as calcium carbonate. And if you're in that range and have what we would consider to be hard water, a water softener would typically be the treatment that most people would choose to counteract the aesthetic issues that might occur as a result of hard water. There's also the flip side of too much hardness, which is too little hardness. And we call that soft water, which would occur at levels less than about 150 milligrams per liter. And people with soft water, the concern there is that there's a lack of ions, and that lack of ions causes water to be more corrosive or aggressive. So in the condition or the situation where the water is less than 150 milligrams per liter, people might choose or investigate what we call an acid neutralizer to maybe counteract negative effects that might result from corrosive or aggressive water. And then there's this kind of ideal range of hardness between about 150 and 200, where you're not going to notice the problems associated with hard water, and you're probably not going to associate or notice the issues with soft water. If we look at the results for the total hardness for this current year, year 3 of the project, what we see is the average concentration is about 346. The median concentration is 356 milligrams per liter. That median concentration is the level at which 50% of the samples or half the samples are greater than that number, and half the samples are less than that number. So that's kind of what that median value represents. It's very similar to an average, but it's a little bit more robust when we have really high or really low values. So it's just another way of looking at what's a typical concentration of total hardness in Greene County. You'll see the maximum concentration was 589 and the minimum was 62. The map on the left is giving you some indication of where the high values, where the low values occur. And there are some patterns that emerge that we'll explain in a little bit more detail in the next couple of slides. When we look at alkalinity and pH, the reason we do these tests are that alkalinity, again, is giving us some insight into how corrosive the water is, or how likely is that water to form scale. And the numbers, the way we interpret the alkalinity values, are very similar to how we interpret the hardness values. Alkalinity is kind of the inverse or the opposite ions to the complementary ions to the total hardness. And they come from the same rock, the same minerals. And as a result, the alkalinity and hardness values are usually about equal or roughly equal in most well water samples. If the alkalinity value was much greater than the hardness value, then that probably is an indication that that water sample had passed through a water softener. And the hardness value in that case is a reflection of the softened water, not necessarily the actual well water. pH, many people are familiar with. It's a measure of water acidity. It, like alkalinity and hardness, can be used to help understand how corrosive or aggressive the water is. We know that things that are less than 7 tend to be acidic. Things that are greater than 7 tend to be basic. Typical pH in Wisconsin is anywhere between about 6 and 9 on that pH scale. If we look at those alkalinity values, what you see here, the average was about 307, the median was 315, the maximum was 479, and the minimum was 32. The higher values are shown on that map in the blues, with the darker blue values being the highest. And then the lower values are going to be the orange, orangish color. And the pattern for alkalinity is very similar to that pattern we saw with total hardness. Lastly is the pH here. The average 8.1, median 8.14, maximum 8.5, and the minimum 6.7. If we look at those three maps together, again, you see, generally speaking, where you have the lower alkalinity values corresponding with the lower pH and the lower hardness values. Just selecting one of those parameters and helping illustrate why those patterns exist, we can look at some of the geologic maps. The map on the upper right is showing you the uppermost bedrock units that we would encounter when drilling a well. And the lower map on the lower left is showing the depth to bedrock. So that depth to bedrock map is essentially the depth of the unconsolidated materials that have been deposited over the years on top of our bedrock aquifers. So the areas where we see generally the low alkalinity, low hardness values are in those areas where we have the deeper unconsolidated materials. Those would typically be things like sands and gravels that oftentimes don't have as much carbonate. They don't have as much calcium or magnesium or alkalinity, and therefore the water quality that we get from those aquifers is going to show different water quality profiles from what we might expect in other parts of Greene County. In general, again, those lower alkalinity, lower hardness values we're going to find in those river valley areas of the Sugar River here in Greene County. Next test that we performed would be chloride. Chloride is a test that is impacted by land use activities, and the numbers we can use to help interpret whether the concentration is reflective of natural conditions or if the levels are greater than 10 milligrams per liter, start to suggest impacts from human activities. There is no health standard associated with chloride in drinking water. However, from an aesthetic standpoint, levels greater than 250 milligrams per liter can provide or give the water kind of a salty taste. And water with really elevated levels of chloride might also contain elevated levels of sodium, which could be problematic from a health standpoint, especially for sensitive individuals that might have high blood pressure or be on low sodium diets. When we look at where the chloride might be coming from, we have to consider sources such as agricultural fertilizers, and those would be mainly potash. Potassium chloride type fertilizers would be a potential source of chloride to groundwater. We would have to consider septic systems, particularly septic systems with drain fields that are serviced or have water softeners installed on that well water system. Lastly, we might be concerned about road salting activities. So areas with a lot of impervious areas or major highways where de-icing activities during the winter would be using a lot of times products that contain chloride that when the snow melts in spring would carry some of that chloride into the groundwater system. If we look at the chloride results from 2021, what we see, only about 1% of the wells tested greater than 100 milligrams per liter. So we aren't finding really exceptionally high levels of chloride. However, on the flip side, only 37% of the wells tested less than 10, which would be kind of the ones that we would consider to be at background or natural levels. That means that there's a significant number, about 63% of wells, that are probably impacted to some degree by the land use or surrounding activities. Average concentration was 18.9. The median was 15. The maximum was 190, and the minimum was less than 1. Not unusual if you look at that map to see some of the higher concentrations near the municipalities or the kind of villages or cities that are in Greene County. So City of New Glarus, Monroe, outside of Broadhead. Again, not unusual to see higher concentrations where we might have major roadways or, again, more impervious areas as a result of various development. Next would be the nitrate test. This, as is the case with chloride, is another great indicator of land use impacts. Nitrate, however, does have health standards associated with it. So natural levels would be levels less than 2. Greater than 2 would start to provide evidence of human impact. And then greater than 10, we would consider that water to be unsuitable as a drinking water source, primarily for infants less than 6 months of age and women who are pregnant or may become pregnant. But really, we'd like everyone to avoid long-term consumption of nitrate above 10 because of the unknown health effects and the emerging data and science regarding health effects to all populations. When we look at health effects related to nitrogen or nitrate in particular, with infants, the concern is methemoglobinemia. The common name is blue baby disease. This is a condition that can be fatal if left untreated. And then with women who are or may become pregnant, there's possible links to birth defects and miscarriages, not only in humans, but also in livestock. So if this is a well that's providing water to dairy cows or horses or even pets who may be pregnant, possible links to birth defects and miscarriages would apply to those animals as well. And then with respect to everyone else, there's the science is a little bit less certain, but there's data to suggest linkages to things like thyroid disease or increased risks of certain types of cancers. When we consider the sources of nitrate to groundwater, it's really nitrogen fertilizers. So those might be agricultural fertilizers. It could also be lawn fertilizers. We'd be considering animal waste or other biosolids that are stored or spread on the landscape. And we'd also be concerned about septic system drain fields, which human waste, just as animal waste, contains nitrogen. And when that's discharged to a drain field, some of that nitrogen is going to be converted into nitrate, which gets into our groundwater as well. If you do have elevated nitrate levels, ideally, we would like to work towards eliminating the source of that contamination, or at least reduce the nitrogen inputs so that the water that ends up in groundwater is providing lower levels of nitrate that meet safe drinking water. One thing that we have to keep in mind, that even if we eliminate that contamination source today, it could take years or decades to notice measurable improvement in somebody's well. So as a result, we often have to look or investigate the potential for short-term solutions, things like changing the well depth, looking at purchasing bottled water, or maybe installing some sort of water treatment device, such as a reverse osmosis, distillation, or anion exchange unit. Those are the 3 types of treatment units which are capable of removing or reducing nitrate. If we look at the nitrate and chloride maps, again, we said this is related to land use. So if we look at particularly the agricultural land cover, oftentimes there's patterns between where we see, some of the higher concentrations of nitrate and elevated levels of chloride with where we might find certain agricultural classifications or categories. Row crop systems tend to be a little bit more problematic for nitrate loss than perennial systems. So those areas where we see a lot of continuous corn or cash grain, it's not unusual for those regions to have, more impact, as well as higher concentrations of nitrate in the groundwater. And that's kind of, one of the questions that we hope to investigate further in years 4 and 5 of this project. Highlighting nitrate and the results as we have seen them over time. We see the map on the left representing the most current testing here in 2021. But if we look historically at those averages, what we're seeing is that, the overall average for something like nitrate at the county level has remained or been pretty consistent. There are some changes. Really important to point out that the number of samples has declined. So this isn't a complete apples to apples comparison on this graphic. We are looking at demonstrating or visualizing this in other ways, where we just compare the wells that have tested in all 3 years and looking at the average of those wells. But in general, I think what this helps illustrate is that we're not seeing dramatic changes from year to year. The changes that we're seeing are often going to be in individual wells. Those are the changes that are going to be more interesting to understand. Are there patterns to where those changes are occurring? And if so, what's happening around those wells that might help explain the variability? Or in the case where there might be significant trends, what is it about that land use that's contributing to those trends over time? But what we're seeing, again, in general, is that the vast majority of wells are pretty typical, or pretty similar from one year to the next. If we look at the last test, the conductivities test, this is an overall water quality test. Again, this is looking at all ions in solution. So the combination of nitrate, chloride, alkalinity, hardness. It's kind of looking at all of those things in one test. Again, measuring the total ions. Generally, conductivity is about twice the hardness. If it's much greater than that, may signify land use impacts, which could be reflected in elevated levels of nitrate or chloride. One reason we're really interested in conductivity is this, again, is fairly inexpensive to test for. People could probably go out and buy a conductivity meter at a store, or buy one online that would allow them to measure conductivity daily. Or in the future, we may be able to invest in water quality sensors that would be able to measure conductivity continuously in somebody's well. So collecting good baseline data on conductivity might be really useful for developing more real-time water quality monitoring systems to look at, changes that might occur over the course of seasons, or as the result of a large rain event or snowmelt event. Here with this project, we're testing once a year, and that is great. We wouldn't expect most people's well water quality to change very dramatically from year to year, but some wells may be more sensitive to sudden or rapid infiltration of surface water, and continuous measurement of conductivity may allow us some insight into which wells are prone to that type of contamination event. So that's covering the individual tests and a little bit about the results from year 3. Coming up, what's next for the project in year 4? We do plan to send out test kits to all of those participants from year 3, those 307 participants will be sent a sample kit sometime in October or November with the intent that they sample and mail that kit back to us. Also here in year 4, we will be adding new functionality to the dashboard to help investigate those questions of land use, well construction, and trends. We'll look to build on those relationships that we might find in hopes of developing statistical models that will allow us to better predict water quality risk for those wells that are not part of this project. So it would be great if we could have sampled or reached out to all the well owners in Greene County, but just as a result of funding, that's not possible. But through this program, the information we're collecting will benefit all residents, all rural landowners of Greene County, thanks to the information that we're learning and gaining from this program. With that, I'd like to do a quick demo or update on the dashboard. I'm just going to navigate to a different screen real quickly. And as I share my screen, you should see the Greene County Well Water Monitoring Project dashboard. I'll highlight the web link that will allow you access to the dashboard. This is the updated version that is currently not live, but in the next couple weeks, or for sure the next month, the dashboard will be updated to include year 3 data for the project. But some of the functionality that's really important to know or understand how to use it would be the map type. What you're seeing now is individual wells. We can click to municipality and see kind of the average or the statistical summary by town. If we wanted to look at past years, we could obviously use the year to navigate to the different years of the project. We can also use the variable tab to select from the different analytes of the different parameters that we tested for, and allow people the ability to kind of see what those maps look like and interact with them. If they were interested in, let's say, a particular well, you can click on that well. It provides the well ID. The well ID is that unique project ID that is only known to the project participants. So project participants need not worry about their data or people being able to view their data and know which point is associated with which well or which parcel. This is the furthest that somebody could zoom in. So it's really hard, if not impossible, to know which data point belongs to which parcel or which property. Other functionality that is built into this website, there's learn about the tests if you had questions about the individual tests and why we perform them. There's also this explore project data, which allows you to look at things like trends over time. So this again is helping us kind of visualize from year to year what is the overall kind of results and what we've learned for the different analytes that we're selecting from. We can look at individual wells, where if somebody knows their project ID, they can select their project ID and see what that historical data for their well looks like for nitrate, for chloride, as well as all the other parameters that were included in each year of the project. There's summaries by municipality, which are interactive and allow you to see from town to town what is the kind of summary statistics, or what is the comparison of the various analytes and a town by town level for individual analytes as well as the different years. And then lastly, some of the things that we're building into this dashboard are the ability to kind of look or investigate different aspects of things like well construction, or things like a land cover or aquifer type, or soil drainage classification. Those are factors that are going to be really important for helping us assess or understand why water quality is a certain way in Greene County. So that's a quick overview about the dashboard. Again, we'll provide additional information on that dashboard in the upcoming newsletter, which we hope to distribute this summer to participants of the program, kind of providing them an update on the project, as well as some of the new or additional functionality and information that we're learning. What you see here is just a screen capture of that dashboard. The website address is listed below. For participants, that website address should also be contained in the cover letter that you received with your test results. And with that, I'd like to conclude year 3's annual kind of summary of the well water monitoring project. I'd like to thank our sponsors. That would be Greene County, who is funding the project, the University of Wisconsin-Madison Division of Extension, Greene County office, the Greene County Health Department, the Greene County Land Use and Zoning Department, and the Greene County Land and Water Conservation Department, who have all provided support to this project. For those that may have questions, feel free to reach out to me at the phone number listed or the email address provided. With that, thank you for your time. And we hope to continue testing your wells and reaching out and communicating with you in year 4 and 5 of the program.